All right, so today's lesson is lesson number 61. We are going to be solving linear and quadratic systems. Okay, so remember we had systems of just linear equations, right? We had two lines, and the solution was where those lines cross or intersect, right? So this is the same thing. We're just going to be looking at the graphs, but instead of two lines, we're going to have a line and a quadratic. Okay, remember that U that we've been talking about, the U shape up or down? So picture in your head, if you have that U-shaped graph, right, like this or like this, do you see how a line would hit through, like if I had a line like cutting my body in half, right? It would hit the parabola in two places, right? So we don't just have one place where they could cross in two places. Okay, so these are the steps on the right. Are we good on the lesson title? Can I move on?
Yeah.
Yeah? Okay. All right, so here's our steps. Again, very easy, okay? Short, 3 little steps. You're going to start by looking at the two functions. So just kind of look at what you have in front of you. See if it, what's going on, what the trends are. Then you're going to read the graph from left to right, okay? So just like you read this sentence, you're going to read the graph from left to right, go across the x-axis, and see where the two functions intersect. Okay, so you're looking for where they intersect, and then those points you're going to write as ordered pairs, and those are your solutions to the system. Okay, so a few more seconds to write these steps down. All right, so here's our first two examples. Okay, so number 1, I have a quadratic, right? Negative x squared plus 2x plus 1. Do you guys see the negative in front flips it upside down? Right? So we have an upside down u. And then x minus 1 is a line with a slope of 1 and a y-intercept of negative 1, right? So that's this line right here. All right, so I'm going to read the graph from left to right, and I see as I'm going across this way, they intersect first right here. So I'm going to write that point. It's the point negative 1, negative 2. So I'll go ahead and write that point. Okay, and then if I keep going to the right, they intersect again right here. This is the point 2, 1. And I'm done. That's it. Right? So that's where they intersect. I wrote them as ordered pairs. Those are the solutions to the system. So what I could do if I wanted to be a really good student and check my work, this was on a test and I wasn't completely sure, I could always plug these 2 points back into these equations. So for example, 2, 1, right? If I plug it in here, do you see that 2 for x, 2 minus 1 is 1. So I have 1 equals 1, so that is true, right? And then the same thing would happen if you plug that point into the quadratic. I'm not going to do that right now because I can see very clearly that those are the 2 intersection points. Okay, but that's always a strategy that we can use, right? We can always check our points in the system. Okay, I'm going to move on now to number 2. I move going across from left to right. I see they intersect first right here at 0, 2. Okay, so I'll write 0, 2. And then as I keep going to the right, they intersect again right here at 3, 5. So my next point is 3, 5. Okay, any questions on how I'm getting the solutions here? It's just looking at the graph, right? Looking at where they intersect. Okay, so next we have number 3. I have a quadratic. I see this is vertex form. So right away I know the vertex is negative 2, 3. If I check on my graph, negative 2, 3. Yep. And then this is a line that has a y-intercept of negative 1 and a slope of negative 2. So that's that line. And again, as I move across, I have some intersection points. Really quickly, talk to your partner, get those 2 intersection points. Okay, where do those 2 functions intersect? All right, go ahead and raise a hand if you want to give me the first point right here. Guys, did you hear that? All right, the first one is what?
-2, 3.
-2, 3. Good. And then what's the second intersection point? Someone on this side of the room. Okay.
1 and -1. -1, 1.
-1, 1. Good. Okay, number 4. Do you guys see an intersection point on number 4?
Nope.
No, right? This line doesn't touch the quadratic. Is it ever going to? Think about what would happen as I go farther towards negative infinity.
That the U is gonna spread out more, and it's gonna eventually touch.
Well, let's think about this. So this one's always going like this, right? This has a constant slope. It's going up and out. This one is going up, but if you were to look at the graph of these, they go up very steep very quickly, okay? So they get really, really big really fast. So this is almost turning into like a vertical line, and this is going way this way. So they're actually going to get farther apart. Look at how far they are here, and then how far they are up here. So they're already getting farther apart. That's just going to continue. Okay, so again, we can see here they're kind of close, farther and farther and farther, and that trend would continue on. Same thing down here as x goes to infinity. Here, y is going to infinity, right, on this graph. On this function, as x goes to infinity, y is going to negative infinity. So those are definitely never going to cross back over each other, right? So for that, we write no solution, just like for our lines. When they never intersected, when we had parallel lines, we would have no solution. So the same is true here. We write no solution. Okay? And then, so we've seen I can have 2 solutions and I can have no solution. So here would be an example of having 1 solution. Okay, if I have this, oh, sorry. I undid it. If I have this line right here, that would give me 1 solution, right? They would intersect just at the vertex point. Okay, so that would be an example of how I could have just 1 solution with a line and a quadratic. Okay, and then I could also have a line going this way, and that would give me 1 solution as well. Sorry. Okay? So 5 and 6, thank you. 5 and 6, we aren't given the graphs, so I'm going to use Desmos, right? That's my graphing tool. I don't want to really graph this, right? That takes a lot of time. I could, but I don't want to. So I'm going to show you number 5 on Desmos, so we're going to click over to that really quickly. Okay, so number 5, I already have these equations written down. Yeah, go ahead and you can go to this on your iPad. I know some of them are dead, but just kind of look at your partners or someone in your group. Okay, if I show this first equation, you'll see that it is a parabola, right? Or a quadratic. Excuse me. There's another word for it. Okay, so I have this quadratic, and then this line is intersecting it twice, right? So I can zoom out and try to see what those intersection points are, right? Okay, so I get these as my intersection points. They're not exactly nice numbers, are they? No, but they still intersect there, okay? So a line and a quadratic aren't always going to intersect in a nice, neat number, okay? So this tool shows me exactly where those intersection points are, even though they're not nice numbers, right? Even though there's some kind of funky decimals going on. So those would be my 2 solutions to this system, okay? So do you guys see how we could use Desmos as a tool for these problems?
Yes, ma'am.
Okay, thank you. And now we're going to do number 6, okay? So I'm going to click back so we can see those equations. Okay, so here are the equations for number 6 in the graph. You can see, how many intersection points do I have now? What do you guys think? Talk to your partner. How many intersection points are there?
1, 2, 3.
3, right? Which is kind of different. That's cool, right? So I have the vertex point here, both of them intersect, and then I have these 2 points on the side, so I can click on these points, right, to get a better idea of what they are exactly. Okay, so those would be my 3 solutions to this system for number 6. Okay, so if you don't have an iPad, look up at the screen, see how we found those, or look on the people around you on their iPads. Okay, so again, this is just a tool that we can use if we aren't given the graph. Okay, we can always use Desmos to graph our functions. Okay? All right, well, that's going to be all for today.